Imagine you're at a party, and every time someone speaks, you write their sentence on a sticky note and tape it to the wall. After a few hours, the wall is covered. After a day, you can't see the speaker anymore. You're still responding, but you're drowning in your own notes. That's what happens when an AI model processes a long conversation. It builds a memory backpack of everything said before. This backpack grows with every word, slowing everything down and costing more money. Nobody talks about it much, but it's the single biggest cost problem facing AI in 2026. Training is when an AI model learns from data, a student studying for a massive exam. Inference is when the model uses what it learned taking that exam. Training happens once on expensive GPU clusters and costs millions. Inference happens every time a user asks a question, runs billions of times a day, and costs far more over the lifetime of a deployed model. Training is buying the library. Inference is every person who walks in and starts reading. The people reading it, that's the ongoing bill. When an AI generates text, it needs to remember everything said previously. In transformer models, this memory lives in the KV cache key-value cache. Every token processed gets a key and value vector stored at every model layer. The problem, the cache grows linearly with context length. A 70 billion parameter model needs about 140 gigabytes just for its weights. Add a long conversation, and the KV cache adds tens or hundreds of gigabytes more. A single 128K token, prompt on Llama 370 billion, consumes roughly 40 gigabytes for KV storage, the entire capacity of one NVIDIA A100 GPU. Your model is spending most of its memory not on thinking, but on remembering. 1. Context windows are exploding. Just years ago, 0.48 tokens felt luxurious. Today, models offer 100, 000 to 1, 000, 000 tokens. Computational cost scales quadratically with context in self-attention. Jumping from 8K to 128K context imposes a 64x increase in computation per token. The World Economic Forum's 2026 Technology Pioneers report notes a structural shift. AI investment is moving from chatbots towards startups building infrastructure for an agent economy. 8 new companies in the 2026. 2. AI agents are multiplying. Cohort alone sit in this category. Agents run continuously with long-running conversations. They multiply the inference load. Multi-query attention, MQA. Instead of each attention head maintaining its own key-value vectors, MQA shares one set across all heads. This reduces KV cache size by up to 8x with minimal accuracy loss. Meta's LLM models use this. Paged attention, borrowed from OS memory management, this treats the KV cache like virtual memory, swapping infrequently used blocks out. It reduces KV memory by roughly 55%, effectively doubling usable context within the same GPU budget. KV eviction and sparse loading. Newer approaches cluster tokens by semantic similarity and retrieve only relevant groups of past tokens. Some systems discard less important tokens entirely. Hardware, AMD's MI300X offers 192 gigabytes on one card. The push continues for GPUs with massive memory, the physical foundation that makes long context inference possible. OpenAI reportedly spends about $0.00012 per token generated 1 token per 3/4 of a word. Sounds negligible until serving millions of users. Best-in-class infrastructure can be nearly an order of magnitude cheaper per token than average. In an agent economy where systems run continuously, that difference compounds into billions. 1. KV cache optimization will define the next generation of models. 2. Agent infrastructure is real money. The WEF 2026 cohort includes dedicated infrastructure companies for verified identity, billing, and GPU orchestration. 3. The cost gap between efficient and inefficient serving is widening fast.